Hello everyone, you are learning physics from Uncle Irodov. In this module, we will be solving Irodov's 1.4. Now you have seen the problem statement. There is a ST graph given and they are asking us to find out three things. The first of which is average velocity. Now average velocity is the displacement divided by the time taken. So this is the displacement, this is the time taken. We know that the object has a displacement up to 2 meters. So that is the value here, and the total time for which it travels is around 20 seconds. So that is here, giving us the velocity as 0.1 meter per second. This would be the slope of line drawn from origin to this point marked A in the figure. This is V average. For the B part, he is asking us the maximum velocity of this particle. Now because the slope of displacement versus time graph gives us the velocity, the steepest slope will give us the maximum velocity. The steepest slope of this ST graph is in this region, which I'm shading with pink right now. So to find out this slope, we can perhaps use this point, which is 1.8, and the corresponding value of t will be 16, and this point, which is around 0.4, and the corresponding value of t will be 10. If you use these values to find out the slope will turn out to be around 70 by 3 centimeter per second. So this is an estimate of the maximum velocity of the particle. I'm just saying an estimate because by choosing some other points in between, we may get a slightly different answer. For the C part, he's asking us the moment at which instantaneous velocity is equal to mean velocity up to that time. Now, how do we find out V average? V average is delta S by delta T, which is R final minus R initial by T final minus T initial, which is R final minus 0 divided by T final minus 0 if I take the origin to be the initial point. And then R final and T final are the coordinates of any general location on this curve. For example, I can take a point on the curve like C, and then this straight line, the line going through the origin and C, will give me the average velocity from t is equal to 0 till the time the particle arrives at C. And to find out the instantaneous velocity at C, I will have to find out the slope of tangent at C. Clearly in this figure, they are not equal. Then he is asking us for a point where these two values become equal. That point may be somewhere near this portion, say D. If you draw a tangent to this curve at D, and if you draw the straight line from origin going through D, their slopes will be close to each other. By moving around D in the vicinity of this region, we will get to a point where the slope of tangent exactly becomes equal to the slope of line from origin to that point. That is shown in this sketch below. So the point that we are trying to look for should be somewhere in this region. It should be between t is equal to 16 to t is equal to 18 seconds. So during this interval of around 2 seconds, there would have been at least one such point where the instantaneous velocity would have been equal to the average velocity from the initial time to up to that time. I hope that you have learned something from this video and hoping that you will be visiting more of my modules.